this is our transition to muscles, is the somatic nervous system. We've got like one slide for this. Somatic, again, voluntary or involuntary? This is voluntary now, okay? So we're trying to control skeletal muscles. And the idea is, we're innervating skeletal muscles, and rather than having the general pathway in the autonomic is 2 neurons, here we only have 1 neuron. There's only 1 neuron between the CNS and the effector organ. So over here, I can draw, we have our general autonomic pathway, and then this is going to be general somatic pathway. So we have 1 neuron between the CNS and the effector organ. So here's the CNS, here's my neuron, and it goes all the way to whatever your effector organ is. And in this case, well, it's generally going to be skeletal muscle, right? Effector organ, skeletal muscle. Now, this motor neuron, what should it be releasing? You can already logically figure this out. It should be releasing acetylcholine, absolutely. So if this is releasing acetylcholine, what type of neuron is this? Neuron that releases acetylcholine. It's cholinergic. So this has to be a cholinergic neuron. So your motor neuron releases acetylcholine, and these receptors over here on the skeletal muscle, we had already talked about that. What type of receptor? Cholinergic. More specifically, they're going to be what? Nicotinic cholinergic. Good. Because that's the slide that we set when we looked at where the location of nicotinic cholinergic receptors are. Okay? So the effector organs, you're going to see cholinergic receptors. I would correct that and write nicotinic cholinergic just so that you know the specifics. It will be nicotinic cholinergic. Just to clarify. Okay. Any questions so far with this? Either autonomic, general, or autonomic, oh my gosh, why am I slow? Somatic or sympathetic versus parasympathetic. Yes?
Just want to double check. So you said cholinergic receptor. What do you think?
I can't, I heard like every other word. One more time?
Earlier you said, just to be clear, to write down nicotinic cholinergic receptors, right, on the effector organ?
Yes, it should be nicotinic cholinergic receptors over here, as written nicotinic cholinergic receptors there. If you don't write it down, it's not the end of the world, because if you look at the other part of your notes, it says that that skeletal muscle is going to have nicotinic cholinergic receptors anyways. I just want to keep it clear. That way you're already starting to know that, hey, skeletal muscle is nicotinic cholinergic receptors. Yes? Effector organ / skeletal muscle. That's SKLLMM or whatnot. Skeletal muscle. I'm sorry, the green is horrible. Okay, let's go ahead and take a look at this. The autonomic nervous system innervates all of the following except it should be pretty straightforward, guys. Autonomic does all the following except which one? B, good, skeletal muscle. Moving on, the parasympathetic division of the ANS. Parasympathetic. Which letter? D has effectors through the sacral portion of the spinal cord. That's true, okay? Parasympathetic is what and sacral? Cranial and sacral, okay? Thoracic, no, that's gonna be sympathetic. GI should be increased, pupillary should be constriction. Actually, wait, what? Yeah. Yeah, sorry, I just stopped for a second there. Yeah, it should be pupillary constriction. Okay, my bad. Okay, several soma in the PNS is called what? C, that should be called a ganglion, perfect. Postganglionic neurons of the sympathetic system have what receptors? What letter? A. Okay. I'm trying to right now. Without, okay, yes, okay, so postganglionic neurons, this one over here, okay, of the sympathetic, it really doesn't matter, I didn't have to say that, of either one, right? Sympathetic or parasympathetic. What receptors are they gonna have? Well, here are the receptors, nicotinic cholinergic receptors. Does that make sense? Again, whatever I ask you here, knowing this image is what's gonna, kind of get you there. Adrenergic receptors. Letters? Or D, all of the above. Can respond to norepinephrine? Yes, they can. Can respond to epinephrine? Yes, they can. Can be either alpha or beta. In subclass, yes, that's true. So it's D, all of the above. Perfect. All right, let's go ahead and move to muscle. All right, so we're going to talk about skeletal muscle now, all right? So depending on who you had in anatomy, usually students know a lot about muscles already, right? So I feel like our anatomy program does a pretty good job of covering that. So you'll see a lot of it will be kind of a review, which is nice. A couple of steps you'll go in just a little bit deeper, right? Just to get a little bit more of the specifics in there. So, the first thing we're going to do is we're going to look at skeletal muscle, we're going to look at the structure. So if you recall from anatomy, and if you don't, it's okay, it kind of depends on who you have. The structure of skeletal muscle is super layered, right? You're going to have like a bunch of cells inside bundles, etc. Okay? But before we get to that, there's something called a tendon. Remember, a tendon is going to be basically muscle to bone or bone to bone? Muscle to bone, good. A ligament is going to be bone to bone, and a tendon is going to be muscle to bone. So this is, tendon is specifically connective tissue that is going to be connecting to bone that kind of helps to connect your muscle to your bone. That's the idea, that's what these tendons are. Now, the body of a muscle, or the belly of a muscle, they can be used interchangeably, you might run into both of them. Body or belly is the meaty part of the muscle. So the chunky, meaty part, so the fattest part of your muscle, that is the body or the belly. This is the part that's going to generate the most amount of force, hence that's why it's the meatiest part. When the muscle fibers or the muscle cells contract, that is going to pull on the bones or the skin, and that's how you're going to get movement. So that's the general idea. So we can start to see what this looks like. So I'm going to draw a bone over here. This is just like any bone. It's not like a bone in the human body. It's like a Flintstones bone. But so here is bone. All right. So coming off of this bone is going to be some type of muscle. muscle is red. And we have to have a tendon that's going to attach the muscle to this bone. So here's that attachment site. So this is going to be your tendon. And the muscle, what I'm going to do is I'm going to take the meaty part and I'm going to actually expand it so that way you can see it, and we're going to cut into it. So this meaty part over here, we're going to open it. And you're going to cut into it like this. Okay, so here's all the the different muscles, fibers and whatnot, right? So here's the muscle. I'm expanding it, and then I'm cutting it like this. So there's like a piece of meat. That's the idea. Now, let's look at the structure of the muscle now, and then we'll start to go into it. The body is going to be this whole muscle as a whole, so it'd be this meaty part right here. That would be the whole muscle of the body. So, the function of skeletal muscle, we know this already, it's attached to bone or skin, and therefore is going to cause movement, right? So when the muscle contracts, it's going to pull on the skin or pull on these bones. Okay, so let's go ahead. This whole meaty part as a whole is going to be your muscle. Your muscle as a whole. Moving on. Let's go quick review with skeletal muscle anatomy. Okay, just to make sure we understand this. Your muscle as a whole is composed of a bunch of other bundles. Those bundles are called fascicles. I hope this is ringing a bell, okay? If not, it's okay. We're still going over it, right? So inside this muscle, there are a bunch of other bundles inside. Each one is called a fascicle. And the whole thing is going to be encased in something called epimysium. Go ahead and say that. Epimysium. You guys remember this, kind of? Yes? I don't know. I don't know how well you remember your anatomy, but we'll go over it either way. So right over here, we have these bundles. So each one of these bundles are going to be called a fascicle. And this whole thing, a bunch of these bundles, are going to be wrapped in connective tissue. I'll make it blue here. So this connective tissue that's wrapping around all of these fascicles together. So this connective tissue is going to be called what? Epimysium. Okay, so your muscle is surrounded by epimysium because it is made up of a bunch of fascicles that are that are held together by a bunch of epimysium. So here's one of these fascicles that I'm going to open up. And then I take this, so I'm taking one of these bundles. This is your fascicle. And your fascicle is really a bundle of muscle fibers, okay? And your muscle fibers, you're going to have a bunch of these muscle fibers, and they're going to be wrapped up around in something called perimysium, okay? So here's your fascicle with a bunch of muscle fibers inside. Just so we are clear, this one coming out, this is a muscle fiber. Your muscle fiber is also known as your muscle cell. Okay, so this is your muscle fiber. So you have a bunch of